Hi all, hope you all are doing good. So as discussed in the index, today we are going to learn about two things. Fundamental of system design and second thing, all the principles of the system design. So with that mentioned, let's jump onto the topic. So system design is not something which came in one day or 2 day. It was there from ages, long back ages. Even when people didn't know what is system design, even at that time system design was there, its principle was followed. But the point is, it is continuously evolving every now and then from ages and ages and ages. And the purpose and the way, the methodology, everything differs a bit in each domain, but the interface or the abstraction remains same in all the domains. So the point of saying that is that it is not specific to computer science or computer engineering. It is there in everywhere. It is there in civil engineering, it is there in mechanical engineering, it is there even when we are cooking a recipe. So it's there in every domain basically. Okay, so this term came into existence the first time in the book called Structure Design by Larry L. Constantine and Ed Yourdon, published in 1979. We need not remember this. I kept that just for the awareness, just for the fact. Okay, so before that also it was there, and after that is also it is continuously evolving. Even now, if you go and Google, give me the definition of system design. There is no specific official definition of a system design. If you Google, give me the principles of system design, there is no specific set. Okay, so based on what I am designing the content as the generic. Okay, the one which is followed across all the domains, and the one which is like I can say which is present mostly everywhere. Okay, mostly means definitely it is present everywhere. Okay, so based on that I am aggregating the content and showcasing here. Today we are going to spend covering these two topics, 5 slides, and each term that we are going to come across is going to answer the questions for the upcoming topics. For example, the role of a system design is going to be explained by the definition, and the role of a system design is going to explain us the principles of a system design. So that's how everything is interconnected. Now with that mentioned, let's give a read to the definition. So system design is the process of defining the architecture, components, modules, interfaces, and data for a system to satisfy specified requirements. Overall, each and everything that is required to build a system is what they have mentioned in the definition. Now these terms, if you are not aware, you will say everything is same. Now what is the difference? So let me just throw some light on each term. Architecture, which is mostly concerned about the structure, layout, flow of controls, and all such things. Okay, now components is basically a high level building block. Let's take a common example of a construction itself. Okay, so when we say components, we can say there is going to be 3 blocks in a society. A first block is going to come here, second block is going to come here, third block is going to come here. In each block, these are the number of flats that is going to be there. So these are high level building blocks of a of the system that we are planning to design. So architecture we are clear, component we are clear. What is module? Module is a low level building block of this architecture or the system that we are discussing. So in our case, we can say what take an example. When we are constructing home, what is that piece of thing which is manageable separately? Let's say plumbing is one module. Okay, electricity is one module. Okay, so component is a high level building block, module is a low level building block. Okay, now if you don't know what is high level and low level, very random in a layman's time, I'll say high level means ऊपर का, surface. Okay, low level means in detail, in specific. Okay, now what is interface? Interface again, it I will not say it's a front end or something. Okay, it's completely different context. We are in the context of system design. So interface is basically how each components are related to each other, how communication is happening, how the logic is flowing from one piece to another. Okay, all that thing will come under the interfaces. And data, no need for the explanation. Okay, overall all these things together will help us to form a system. Okay, now what all things it involves, we are seeing architectural design, component design, data design, interface design, and based on this we are going to see the principles of designs and all such. Okay, so the conclusion of all these things that we are learning as part of system design is, by give me a system which is going to work as I'm asking for my use case. That's it. Okay. Now if I give a work to one person, he can do it in 10 rupees, another person will do it in 20 rupees, third person will do in 100 times more cost. Okay, so what is it that makes that much difference is what the principles of system design is, what the differing piece, or of how good a system is, how bad a system is, on what scale can we compare, all such things. Okay, so conclusion is build a system, but how good, how bad, and all such things. Okay, with that mentioned, let's move on to system design goals. So what is the purpose or the goals of a system design? First, functioning of it. Overall we have 1 2 3 4 5. Okay, so what is the first goal? Functioning system. Simply build the system that you are planning to have must and should have all the functions that as a client I'm asking you to build. Okay, just because you want to have it secure doesn't mean, let's say you want to secure the application, so you'll remove the payment feature. That's not viable, right? That's not feasible. So functioning system means include all the function that as a client I'm asking. Optimizing performance. Now once everything is working, make sure it works more smoothly. Let's say when I'm making use of a website, it's working but it's not smooth, so can you make it more smooth? Let's say in technical term, can you do DB performance tuning, can you improve the response time, and many such. Okay, so first, function should be working. Second, it should be working more optimizably, more optimized. Then scalability. Let's say Flipkart. Okay, it's there, it's working, it's perfect. Now when there is a big billion day, it should work more than the usual. Okay, so the number of computer, let's say two instances or two systems are running usually. Now when the request comes, it should be able to increase automatically. 10 systems should work, and when the request is not there, calm down. So scalability is basically increase or decrease as per the requirement. Yeah, now there are much more things to discuss about scalability, but we have a separate dedicated sessions for them, so as of now we are not going to touch base on that. Okay, now fourth, maintainability. So the system must be designed for the ease of maintenance, clear documentation, modular components. Basically, when let's say I'm working on a system, okay, and then someone else is going to take up after you. If he or she doesn't understand what is it that you did so far, then how they are going to run the application? So it's not good. Okay, so the documentation, let's take our example that we are taking about the house construction, the society construction. So proper internal audits, proper watchman, proper security, everything, and how each thing is working and where can we see everything. So everything should be transparent, everything should be visible. Is it being cleaned properly or not? If that is not, then whoever comes later for the look after of the system will not be able to manage it at all. Okay, continuous patching to increase the life cycle and all such things should be happen. So this is one of the purpose of the system design. Now why it is coming as part of system design is because if it is not considered, then the system will be managed, but because as part of system design you did not consider maintenance, definitely the output, the system that you are going to create is not considering these bullets, resulting in the bad system. Okay, now with that mentioned, cost minimization. So all these factors are doing the same. If these are not considered, system will still be there, but if these are considered, system will be good enough. Okay, cost minimization. So you are able to do the work perfect. Now what all places where you had a scope of improving let's say performance or decreasing the cost? Let's say two people are assigned initially because they had limited knowledge, but now because you have sufficient experience, one person can handle it. So that was just a rational example. Okay, so these were the 5 goals of a system design. With that mentioned, we are coming on to our last topic. So this is the last topic, but very crucial, very 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 crucial. Okay, and with this we are going to understand that we are learning all these things. What is the challenge? There is only one challenge. Let me be very clear, there is only one challenge, which from the decades till now, and for sure for the many upcoming decades, we are going to face that challenge. So what is that challenge? Let's talk about that in next 2 minutes. So coming to the principles of a system design, first it is abstraction. So what is abstraction means? Abstract means show me less possible details. When I go to shop, I say give me that XYZ product. He will not tell me that how it is being built, from where, which vendor he got it, on what price he bought, and what price he is selling me, what is the profit. No. Okay, let's take one more example. I will say I'll just raise a complaint that my XYZ service is not working. Can you look after me? He is not going to give me entire flow, right? For example, I raised a complaint that my internet is not working. He is going to raise a ticket and resolve it. He is not going to explain me entire thing. Okay, so same thing is happening with the system also. Okay, it is the process of hiding the implementation details. How the thing is happening has been hidden, just the output. Okay, this is what going to happen with this service. Okay, if you click button 1, this function is going to work. That is abstraction. Now why it is being considered as part of a system design? Because when you are doing the architecture, there are multiple layers of architecture. So at what layer, what amount details need to be exposed, that needs to be considered with the help of this modularity. Okay, you are talking about architecture, you are talking about component, are you talking about module, are you talking about interface? So what detail is relevant at what level of architecture, all that thing will comes under the abstraction. Okay, and of course it is going to help us in the designing of the literal programming interfaces as well. We are going to see that as part of the design pattern, but yeah, example. Second point is modularity. It is the practice of breaking down a system into smaller independent components. So we'll take an example of a common use case, e-commerce again. Your courier service should not be dependent on whether the availability of the website, right? Your website availability should not depend on a specific vendor, right? It should not be dependent on the weather. And your payment should not be dependent on whether you are doing it from the mobile, or whether you are doing it from the laptop or system. So there are all these things which are independent of each other, though there is a flow, but it is independent of each other. So your login should not stop you from searching. Okay, so logging is one thing, searching is one thing, but again there is a dependency between when you are adding it to the cart and whether you are logged in or not. So how much one should be related to each other, and what level of dependency should be maintained, and whether each are independent of each other. So these things is what we are going to see in the next two bullets, that is cohesion and coupling. So overall modularity is basically divide your system into smaller pieces. So again, for few bullets, payment is a separate component, courier is a separate component, adding to the cart is separate component, searching is a separate component, registering is a separate component, logging is separate components, right? Okay, now next thing is cohesion. So cohesion and coupling, both of these things comes under the modularity principle itself, but still I added it as a separate because it's kind of a critical, we can say. Okay, so cohesion is basically the level of dependency. Okay, so let's say when I'm saying login and register should be there in one microservice, so what level of dependency is there? Okay, both are dependent on authorization, authentication, both are dependent on the databases. Okay, now if I ignore few technical terms, okay, so what example can I take for a cohesion? So let's take an example of a service called landscaping. So when I say landscaping for a society, it will include the greenery, pots, trees, okay, cleaning leaves, maintaining the shape of the trees, and all such things will be there in the one service. So this is called cohesion. So you define a specific responsibility, you define few factors, and then you decide, okay, so all these things are present. Is this relevant responsibility? Is this falling under the same domain? If yes, all those together is one microservice. Okay, so the intention of cohesion is only the dependent elements or relevant elements or elements of a family should be together, be created as a microservice. Okay, now coupling is basically, let's give it a read example. Cohesion should be more, only then it should be part of one service. Coupling should be less. So let's read an example and then we'll come back. Basically, cohesion and coupling are two extremities of modularity. Okay, so coupling is the degree to which one module or system is dependent on the other system or module. Okay, now as we discussed, coupling should be less. It should be, a system should be loosely coupled. If it is tightly coupled, it is a monolithic. Okay, so it should be loosely coupled. So what is it? If you are developing few systems, okay, let's say you are developing a society, in that you have multiple services. Okay, so the services should be in such a way that there should be least possible dependency in between one another, so that we have, that is what microservices is. So overall, as of now, let's understand coupling is basically the dependency of one module of or one service with another service. Okay, cohesion has different, coupling is different. So these are a bit confusing initially, but you can say for a good system, cohesion should be more, then only it will be part of a service. Coupling should be less, then only it is called a good system, so that there is a less dependency among everything. Okay, if everything is dependent on each other, it's got messed up. It's a waste. Then if one component is failing, the complete system is fails. Okay, so with that mentioned, let's move on to the next piece of principle. So reusability. So I think it's, by term itself, it is very much straightforward. You create a component once and use it n number of times. So when we are saying use it n number of times, it means it should be designed in such a way that it should be generic, it should be flexible, it should be usable with multiple other use cases. Okay, now compatibility again. So I'll take a simple example. When you are designing an app, okay, if it is specific to Apple, if it is specific to Android, then we can say it's not compatible with each other. Okay, let's take one more example. When you are designing an app, it is there for Android, it is there for Apple both, then we can call it as a hybrid app. Okay, so the more generic or the more usable it is on different platforms, or we can say there's a less dependency on specific pieces, because of which it can be used on multiple platforms. One more example I can say, when you are designing a website, the same can be used in iPad, the same can be used in let's say tablet, the same can be used in mobile, Android mobile or any mobile, the same can be used in Windows laptop, the same can be used in Linux laptop. So that is called compatibility. Now yeah, so reusability, compatibility, these are a bit straightforward. I don't think we need to spend much time on it, but yeah, these are going to play a crucial role in our design patterns and architecture. So that's the reason for keeping them, and I think that is the reason these are part of the design principles. Okay, so then we have extensibility. So what is extensibility? The by name itself, it is like your system should be extensible enough. Okay, so today, once you are done with delivering a future, your complete client requirement is done, it should be in such a way that tomorrow, if it is used by someone else, any new feature comes in, it should be able to be added or injected in the system. Okay, it should be plug and play enough, it should be flexible enough to be easily customized. So all those things will come under the extensibility. Okay, next is scalability. So this, I think we took an example of a big billion day to increase the systems, decrease the systems as and when required. So that is the same scalability. Okay, so scale or increase or decrease. Okay, and again there are multiple types of scaling, when to use which one, all those things we'll have a separate dedicated class or session on it. With that mention, we are coming to final two principle of a system design, and then we'll have a challenge. Okay, so what is maintainability? I think this we have already discussed as part of the definition, but yeah, the same thing as one of the pillar of the design principle. Next, and the final design principle is separation of concern. So what is separation of concern? It is basically, as per the definition that we have seen initially, there was this components, modules, interfaces, architecture, right? So the same thing, whatever the functionalities, features, responsibilities, concerns that we have, all this time together we call it as concerns, right? So whatever concerns we have, we should be dividing it or separating it into different components, modules, interfaces and such. Okay, so that is what we call it as separation of concerns. So why do we need to do that? This allows for the easier maintenance, I think you all will agree, as well as flexibility and scalability. Okay, so that was the end of design principles of system design. Now what is the challenge? Now the trade-off that even we have as of today is, when you are okay, you have multiple these things like security, and then scalability and reliability, and then consistency. So I'll take a very generic example so as to understand. So let's say you want a very strict, very much secure, highly, so many firewalls or so much protection to be there. So what does it need? It needs some cost. Okay, let's say you want to increase more UX, you need to make it more smoother, you need to make it more flexible. What you will do, you will spend more expense on it. So here in this example, the more UI UX or the more smoothness that you want, the more cost is increasing, right? So your intention is, you need to decrease the cost, but you need to increase the UI UX or smoothness of the application. Okay, this is what we actually want, but in reality that is not happening. If you want this more, the cost is also increasing. So at any point of time, you need to trade off. Okay, I have only this much of budget, so I cannot expect more than this level of, you know UI UX, let's say, for example. So there is this trade-offs happening across multiple pillars that we want to achieve as part of system design. So you need to decide, as part of our, limitation, restrictions, environments, and relevancy. So based on all such factors, we need to decide at what level we are fine with what kind of trade-off. Okay, that is the challenge. It depends on each individual use case. So I hope you found out all this relevant as part of our system design first topic, and just give a go through on it again, and I'll put all this on my GitHub link, which you can find in the description. So just go through it before coming to the next session. And that's all for today. Hope you liked it, and if you have any suggestions, comments, recommendation, do mention in the comment section. And don't forget to subscribe and click on the notification bell, in case if you miss it, you'll be reminded. So that's all for today. Have a nice day. Thank you. Bye.